Hi, this is video recording for morphology, leaf morphology, root morphology, and also stem morphology. So my name is Azrilani binti Azmi, matrix number 199381. So I'd like to share with you the first one, the first morphology. Okay. Okay. We will talk about root morphology first. So in root is the function of root is to absorb water and nutrients as a support system, and also as a hormone producer place, as a place for hormone, as a place for to produce hormone. Sorry. So this is the root system part. The first one is fibrous roots. They have many small roots spreading out laterally from the base. The second one is the taproot system, which is the further development of radicle into taproots. The type of root modification is the first one is adventitious roots, which is like pandanus roots. Second one is aerial roots. We can find it in orchid. Buttress roots, broad light or plank light, most probably is trees in a forest area. The fourth one is pneumatorous roots. It can be found near to mangrove swamp area. I'd like to show to you guys. Okay, this is pneumatophorus roots. Okay, at mangrove area. Okay, the next one is tuberous root. We can find it in cassava species and also carrots. There are root nodules in root morphology. It comes from legume family. It contains nitrogen fixing bacterium. The first one is mycorrhizae. Second one is entomycorrhizal, and the third one is endomycorrhizal. Okay, let's show to you guys what is that. What that is. Okay, this is mycorrhizae. This is mycorrhizae. This is entomycorrhizae. Okay, this is endomycorrhizae. Okay, that's all for roots. We move to the next part. It is stem morphology. Stem morphology, it consists of so many things here. So I like to explain one by one. The first one is meristem. This is area of meristematic tissue, which is active dividing. Second one is young stem, which is branch. The third one is roots. They have bark, inner ring, outer bark, and radicle. I like to show this to you guys too. Wait. Okay, this is bark. This is inner ring. Okay, the outer layer of the bark, we have four types of them. The first one is smooth, second one is cracked, the third one is peel, and the last one is scales. This is lenticles. It is spore in the bark. We got two types of branching. The first one is monopodial, which is single main axis. You can find it in all palm. The second one is sympodial, which is consists of main axis and a few of auxiliary branches. If you guys watch Harry Potter, you will know that Whomping Willow trees. Okay, that Whomping Willow is a symbodial branching type. Okay, next one is vine. This is not self-supporting climb. It is a climbing. We can find this in eggplant and also cucumber. Yeah. Next is bud, which is immature shoots. We got two, which is vegetative and also reproductive bud. Bud scales is cover for buds. Scars, nose and internode. This is very important as Dr. Isaf talked about nose and internodes, very important in stem morphology. Okay, this is internode parts and this is nodes part. If you want to see this part clearly, we can found it in sugarcane. Yeah. There are few type of stem modification. Okay, right here. Lot of things. So we'll go through one by one. The first one is runner stolon. You can find it in strawberry, like this. Second one is rhizome. You can find it in ginger, like this. Third one is bulb. You can find it in onion, this. Okay, the corms, you can find it in yam. It's calm. You can find it in sorry, this is bamboo. Yes, and also Oryza sativa. Oryza sativa is in your rice plant. Okay, tuber in potatoes, tendrils. Tendrils, yes, tendrils, thorn, phyllote, cladodes, cladodes in asparagus. Okay, pseudobulb in orchid, and also adenium, if I'm not mistaken, adenium. Sarcatilla in Musa sp, and also in paddy or sp pativa. Okay, let's move to the next part, which is leaf morphology. Okay, for leaf morphology, it's very long topic, so I'll make it short here. So this is part of leaf. We have bud, the base itself, petiole, midrib, lateral vein, venusa, blade, margin, and also apex. Okay. For leaf attachment, there's four main thing in leaf attachment that we need to know. We need to know this. Okay, know this. The first one is petiole. It is a leaf stalk that hold the blade out into the light, preventing shading between leaf and leaf blade. Second one is petiolate with petiole. Sessile is without petiole, and subsessile with very short petiole. This is shell, stipulus, fulvinus. So we got a few type of leaf type, which is simple leaf, compound pinnate, compound bipinnate, compound tripinnate, and the last one is compound palmate, if I'm not mistaken. Yeah. So we go through one by one. So this is example of simple leaf. This is example of compound pinnate. This is example of compound bipinnate. This is example of compound tripinnate. And this is compound palmate. Okay, a few type of leaf margin variation, which is entire, not toothed, dentate is toothed along margin. Serrate is toothed along the margin with the sharp teeth pointing upwards. Leaf arrangement here. The first one is facile. Second one is alternate. Third one is opposite. Whole, decussate, distichous, shape variation. We have is a rose, which is needle shape. Cordate, which is heart shape. This is heart shape, yes. Deltoid, shape like equilateral triangle, 1, 2, and 3 here. Okay, elliptic, Flabellate is a fan shape. Lanceolate, linear, linear in zymase, in corn. Obcordate, oblong, oval, ovate, obovate, sagittate, paltate, this is paltate, spartulate, rhombic, which is diamond shape, apex variation, we have obtuse, mucronate, emerging, cleft, and also clispe. For leaf modification, we have first is brag, the base of flower stalk. If you guys uh, observe of Bougainvillea SP, oh sorry, oh this is yes, Bougainvillea SP, the colored, you thought this is a flower, this is not flower, this is leaf actually. The flower is just small one, is a yellow, is a white yellowish color. Yeah, that one, the flower is here and the leaf is here. Actually the leaf for Bougainvillea, we have purple, we have oranges, we have whites, we have pink, and many more. Okay, for insect trapping leaf, yes, we have few type of insect trapping leaf. Okay, sundew, fly trap, pitcher, productive leaf, thorn, the specialized of leaf part, which is shells, leaf based in Poaceae, okay, auricle is small ear-shaped appendage, okay, ligule, it is outgrowth of projection from the top of the shell. Trichome is a small hairy light. Mostly we can find it in stem parts or at the leaf part. If you guys go through, if you guys observe sunflower plant, you can find the trichome at the stem area. For Brazilian spinach, we can find it at the below the leaf itself. Yeah, this is trichomes. This is the trichomes shape of trichome. Yeah. Variation of the shape variation of trichome, we have four: pieces granula, stellate, bristle tongue, fimbriate, which is hair, and lepidote. In durian leaf, we have lepidotes and stellate, if I'm not mistaken. Okay, that's all for the tree morphology, which is stem morphology, root morphology, and also leaf morphology. So we go to the question part. Okay, let's go to the question and answer part. Okay, for root morphology, the first question is how the root develop. Actually, root structure, it is coradical, which part of embryo it grows out of the seed to develop roots. Is starting point from the radicals. So the second one is what is function of root cap at the root tip. Okay, root cap at the root tip, it act as protective tissue for apex parenchymus. Okay. The third question is three function of roots in plants. I already talked and stated is this in root morphology part, which is first as a support system, second one as for the nutrient and water absorption, the third one is for hormone production part, yes, the hormone production part in the plant itself, for example gibberellin. So the fourth question is type of root modification. For type of root modification, it is adventitious root, area root, buttress root, tuberous root. Buttress root, we can find it in a forest. It is a very big one. The tuberous root, for example, it is Yeah, for example, it is cassava and also carrots. Okay, the last question for root morphology is differences between ectomycorrhizal and endomycorrhizal. Okay, ectomycorrhizal is most in woody plant forest. For endomycorrhizal, it is at herbaceous plants. For mycorrhiza, it is full fungal hyperpenetrate the outermost root cortex cell, but never invade cell. For endomycorrhiza, it is opposite from ectomycorrhiza. So we move to next one is the stem morphology. The type of outer bark I've stated before. There's four. This is four type, which is smooth cracks, peels, and also scales. The second one is apical and lateral meristerism. Apical meristerism is found near or tip of the root and shoot. The function is to increase the length with increase in new cell as primary growth in plant. For lateral meristems, it's found in cork and vascular cambium. It increases in plant and act as a secondary growth. The third question is the type of stem modification. The first one is rhino or stolon. We found it in strawberry, rhizome in ginger, bulbs in onion, culm, tuber, and pseudobulb. The fourth question is the characteristic of cladodes or cladophyll. The stem are flattened and shaped like leaf-like. It having node and very small scale leaf. For example, it is asparagus and cactus. So the last question for stem morphology is difference between monopodial and sympodial. I've talked it before. Monopodial is is a single main axis, while sympodial consists of main axis with few axillary branches. So the last one is question for leaf morphology. The type of four leaf attachment, which is shell, stipulus, pulvinus, and petiole. Second one is explain phyllotaxy in leaf. Phyllotaxy is arrangement of leaf on a stem, and it do not shade each other in order to optimize the photosynthesis. So the next question is four type of leaf. The first one is compound pinnate, compound bipinnate, compound tripinnate, and also compound palmate. So the first question is 5 type of leaf arrangement in plants, which is the first one is basal, alternate, opposite, whorl, and decusate. Last question for leaf morphology, it is difference between elliptic and flabellate shape in leaf. So elliptic, it is oval shape, broadest in the middle of a narrow of 2 equal ends. For flabellate, it is fan-shaped leaf. Okay. Example of elliptic leaf, mangosteen, and example of flabellate leaf is ginkgo biloba. That's all for my presentation on leaf morphology, root morphology, and also stem morphology. Thank you.